Software project. First of all, we will try to get to know each other. And next, we will talk about the MIT Duckietown, and it also happened in NCTU last semester. The motivation is that, yes, let's just build a self-driving vehicle. We wish to make the world a better place. You can imagine that if the technology in your hand can help people, can change their life, how valuable would that be? And lastly, we will talk about the schedule in this class and see what's the right expectation from each other. Okay, so let me introduce myself. I got my PhD in UMass Boston, major in computer science, and I spent 3 years in CCEL, MIT, as a postdoc, so maybe I look different after the torture in MIT. I guess most of you, when you see self-driving vehicle, you will get excited, right? So starting from the top left, so this is the DARPA Urban Challenge MIT vehicle. And you can see lots of sensors on the expensive 3D LiDAR sensors. Okay, and later, after the challenge, Stanford, CMU, they went to Google. So that's the self-driving car you know about. Okay, and in MIT, then SAS, he tried to transform this, those self-driving autonomous system into something that can help people. So this is autonomous forklift. And this is a project from DARPA, that's the military research institute in US. And you can see that most of the sensor has been moved from this vehicle to this forklift. And the motivation is that when soldiers, they want to carry lots of supply or heavy stuff, they can interact with this autonomous machine and get things done. Okay. And wheelchair over here, so this is another transform from the self-driving car. And suppose that you have a self-driving wheelchair, then it can actually improve people's life. And also, this is an autonomous boat, and I was in this project. And this is a competition in Singapore. That's a quite very simple task. You just try to detect a specific symbol on the placard and try to dock your vehicle in the right spot. You can think that this is probably a simple computer vision problem. You can get it done in 2 days, maybe 2 hours, right? But this is in a real world environment, and you can imagine that the light condition, illuminance, or the winds that can change the shape of the symbol. You also need a complete system to interact, to turn the perception into computation, and then do the motion planning, and finally put it in the right spot. So it's probably not as easy as you thought, especially when on the water, and it's quite difficult to control everything very precisely. So let's move on to the Duckietown. So this is the Duckybot you can see over here. And this is actually the MIT Duckietown, and there are a group of, some of them are my former colleagues, and we try to build the whole system in the tiny city, more like a miniaturized one. And the hardware, you can see, pretty cheap. And we want to detect obstacles on the road. Yeah, and the motivation is the MIT Toyota 25 million project. Oh, I am. And we are the first international branch in Duckietown. Oh, this is my landman, former landman's daughter. Yeah, they love it. The motivation is from the C-Cell and Toyota project, that's like 25 million. There was an open house in MIT already to show people what's the basic idea and what can this become a great research and education robotic platform. Last semester over here in NCTU, and we have few internationals and some of the graduate students. Okay. And this course is a robotic vision, so it focuses a little bit more on the vision algorithm side. But at the same time, we try to put together and make the robot doing the lane following. And I also want to announce a very exciting news. We have some connection in the real footwear industry in China. So that was my college roommates. So some people in our age, we go everywhere to survive. And then he's the manager, he's like the boss in the factory. When I told him that I'm doing robotics, and he said that, can I just use a tape on the ground of this factory, and you use your robot to carry the boxes. So that seems like a very easy task, right? So before that, they tried to build like a magnetic or some different track. But you can imagine that requirement can change from time to time. Maybe today I want to go this way, but tomorrow maybe I want to go this way, right? So we want something that can be done very quickly and just put the yellow tape on the ground. So I say, wow, this is just a Duckietown, right? What else can that be? So we already get our robot to do lane following. So how hard could that be? I think for education purpose, we shouldn't work for money. We should work for something interesting and something exciting, something can change people's life. Hopefully, some of you will try to join this competition. And again, we come to the discussion section again. So we have 3 questions. What autonomous machine would you like to build? So you can use your creativity, right? And how can your ideal means suppose you have the technique, you have the technology to get it done. And how can you make the world a better place? And what's the value? So the value means that, okay, I may want to do some drone, it's very interesting, but before you do it, you have to think about like how could this maybe help people and create a value. The value could be, you can count it in US dollars, or you can count it in something else. For example, if you help people to improve his life, that's priceless, right? The value, my college roommate, he also told me that he spent quite some money to hire people. The worker can just try to move the box, put it on the trolley, and push it from A to B. Okay, and then they spend that much money. And suppose you are trying to build and do the same job and replace the laborers, what value can you create? Okay, so before you pick a problem, and you have to think about it. So some of you talk about robotic guide dog, and maybe also some other ideas to help people, right? And let me show you this video. I introduce you Professor Seth Taylor. He was my former advisor. And this is, he created this class in MIT since 2012. Okay? And we want to continue this legacy also here.
Well, I don't know that I'd go so far to say that technology advances hurt people with disabilities. But what you see happening is that when there's some sort of technological advance in the world, and there's a class of people who cannot use it, they're left behind. For the past several years, my colleague
This is Professor Seth Taylor.
I've been teaching a class called project environment where it's multiple students get together.
Brian was there,
One person.
the data center.
Trying to build a solution that will help that person live more independently. One was a project to make a home oven. The project was to make that accessible to somebody who was blind.
Yeah, so they find real clients and try to pair with the teams.
So I lost my sight.
Yeah, I know Paul pretty well. Yeah, he was inside to pursue months.
Family and having meals together, I think it's important. And I used to be in times when the oven was really pretty easy to use. It was turned to dial, essentially. You knew where to position the dial.
Paul has an oven in his kitchen. The reason that he's not able to use it is because it has a flat panel touchscreen on his control panel. Because he's not able to see the screen at all, he is completely unable to use it. But he was very specific about what he wanted to do.
The idea is that when it is lined up properly, when this is mounted onto the display, that the holes will match up and these braille labels will identify.
So a solution could be in hardware, could be in software. Okay, although this is a software, creative software project, don't limit it yourself in software. And later on, people also use the smartphone to do this, the same thing.
So it's really opened up just another opportunity for me to contribute to the household, which I feel very strongly about.
I think it felt like we were actually doing something for someone, so we were a lot more motivated to do everything with all that is going.
We did another project with a person who uses his computer, controls his computer using a head tracker because he doesn't have any useful hands.
Jack is a really bright engineer who happens to have very aggressive MS. And he's currently living in a home in Chelsea that lets him pretty much live most of his day-to-day life autonomously. But for that, he needs to use a computer. He uses it for opening the door, calling the elevator. He's paralyzed from his head down. And so he controls his computer using his head. And through that, he controls the rest of the world as much as possible.
40 years old, went to college in Cornell, got school in contact, that worked in Silicon Valley, 10 years, first coming up, was diagnosed with MS.
Jack's previous solution was called point and click that allows complete usage of a mouse, but not specifically efficiently. If you're Jack, you have to look back at the menu anytime you want to do something different. Our solution tries to remove as much as possible having to look back at the application. Jack's specific system is huge, always has to wear glasses, so there's a tiny reflective dot on the middle of his glasses, and there's one camera on top of his computer, and it tracks the dot. So he moves his head, and his head moves his mouse on the screen.
Now, people try to use eye tracking, or in this case, hand tracking. So this is also some like computer vision. Yeah, what is
computer science to help some people. After this course, I know as long as you take in mind what those people might need, it can be really helpful. But when you just neglect how people use your product when you're evolving it, you can leave people behind that you really shouldn't.
Together with Seth and also John Anner, I also had some previous project about how this autonomous machine can help people. And this is one of the example. This is actually a pretty hard research problem. So the motivation is that in 2020, there will be the Olympics in Tokyo. And they want to just use your smartphone and I want to go from A to B. So you can think that, oh, that's probably easy for local people. That when you are there, you become maybe situational impairments. Maybe you don't read Japanese that well, and maybe the sign is not clear enough, or yeah, maybe it's just too crowded to find useful information. And this is another project. We work with Andrea Bocelli. How many people know about? He's an Italian tenor. I think he has been in Taiwan, and he's like 三大男高音之后就是他。Okay, so he's famous. The research problem is very similar to autonomous machine, especially the front end, the perception, the computation. And the only difference is that there should be interaction, human-computer interaction. So for example, it's a braille device or it's a haptic device. Okay, and I like to show off this photo. I was in Andrea Bocelli's house in Italy. And in his house, he can actually move freely because he knows everything so well, right? But whenever he walks out of his house, he needs assistance. So it's more like he loses the freedom of mobility. So I think that, for example, the guide dog for the blind could be a very interesting application and very useful for them. Okay. And we also want to continue some of the efforts in Taiwan. And we also have also a project working with Tokyo. So 黑石浩教授, he may be in NCTU, but so we want to build robots for dementia. This project actually already started in Japan. So they want to build more like a robot baby. They call it a telenoid, and they can do a remote control for this. And the target is elder people who has dementia. It's a 失智症. Okay, and before that, when I know about this project, and Professor who is also the professor in our department, he is also the manager director in the 工研院 ITI. And he asked me if I want to do this project, and I think that all my robot can move and do some robotic vision. That's more like my expertise. But somehow I feel that this is an opportunity. So for people over 65 years old, it's more like 1 out of 12 has dementia. You can imagine that it's a huge population. Personally, I also think about my grandma. So my grandma is 90-something. She can barely recognize me. But if we have a robot like this, maybe we can slow down the dementia and have a better quality of life. Okay. This is the official MIT Duckietown material. It's open source, but some of you may try it and feel that it's a little bit complicated or difficult for people who don't have red appearance. Okay. So, but don't worry. We come up with a set of steps. So this is from our last semester. We try to simplify those materials so that I call it how to become a Duckietown robotics in 10 days. So it's fairly easy discussion. We will also cover some relevant computer vision and robotics algorithm, but minimally. Okay, so for example, as you have seen it from the video, how to do the camera calibration, but I also want you to know what happened behind the code. So we will also cover some of the basic knowledge about this, and also some kind of, they call it a Hopf transform. We want to detect lines on the ground. Maybe some of you may have the image processing, right? The computer vision class. So yeah, we will only cover some of this, and it's directly relevant to Duckietown. Creative software project, and we definitely want to do some software. Okay, so we will cover the system level development. So imagine that inside is a small Ducky box. The system diagram is like huge. There are so many components and they try to talk to each other. Okay, so this is important. We want to let you know how to build a real system that can actually work. And also how to refactor your code. So that means how can improve your code, or your teammate write something, how can we do it better? And some code review policy. Actually, even in like a school research level, the code review didn't happen that often. But if you are, in, for example, in Google or in like some industry, the code review is necessary. And we will introduce you what's the code review, and we should know it first, right? And we will see how can we put this in practice in our project. And software testing. Okay, so maybe your software will only work in a certain situation, but some software testing, if you learn about Java, you may know about JUnit, right? Or some other testing tools. People, for example, if you don't have background knowledge about, for example, Unix, Git, Rust, etc., we will have some kind of microcredits. So this will become a real credits in our department. Professors in ECE, Professor Wu Binfei, Wang Yulun, Chen Yongping, Yang Guyang. So we have a few professors, we have a team, and we are developing these microcredits, so that the idea is that, okay, you don't know too much about Unix, don't worry, you just come to the class maybe for 1 hour, 2 hours, and you get 0 point something credits. Yeah, but you can imagine that many of them will be very useful for your project development. Okay, and some other technical skills. So if you want to build something, you may want to learn about 3D printing, or learn about Arduino, etc. And this will probably in our team, but I'm not sure if it will happen in this semester. But this is a big picture that we will have a micro practice. So this one is for sure. We will cover this part in our class. Okay, creativity. So that's the question I asked. So actually, no one really tell you what's creativity, right? But yeah, we have experts to have a systematic way to try to help you to escape. They call it inhibitory actions. And then also some other better presentation or communication. So like probably no one also tell you how to write an email before, right? But email sometimes, if you write an email to an MIT professor saying that I like your work, etc., but if you don't write it properly, you may lose your opportunity. Or you want to get into some professor's lab, you need to write an email properly so that you can increase your chance. Okay? So those are also important, and we hope we will cover in the micro credits. Okay, but this part is for sure. So this part will directly relevant to Ducky. All right, and how to work as a team. I think this is the most important thing you should learn in this class. This is important. We want to work as a team. Some code review, how people write different components in the whole system, etc. Okay, so this is included. And this is a big picture, sorry about that. All the material should be in English, that's our working language. But just show you this first. So we are here right now, and we have some other different courses in our department. So we just talked about habitual actions. I didn't say that, that's from educational psychology experts. It's more like people tend to establish some habitual actions based on their experience. Okay, and unfortunately, creative and habitual, they are conflict. For example, like something you are used to do, your comfort zone, inside your comfort zone, it's very hard to become creative. So I didn't say that. That's from an expert. I also would like to encourage you guys to step out of your comfort zone. Or people say, like, think outside the box. Okay. So, for example, your learning style. From high school, the teacher will give you this is what is covered in the exam. And you learn it step by step, and you pass the exam, right? But right now, we don't have the boundary. So there will be a different way to learn it. For example, learning by doing, and we want to do it. So we will, for example, the Duckiebot, we will give you a Duckiebot, and you type in the command, and it will move. But you may or may not know what actually happened inside. You have to learning by doing. Okay, it's not like, you students sit there and wait for professors to go over every single steps. So that part is done. We are not going to use this method in this class. Okay, your working style, time, location, and work with other people. So how many people try parallel coding? Next to your teammates, sit together, and somebody keep talking, bin something, and shift G, and then go somewhere, and then type something. This is the parallel coding, and I can tell you that, for example, the Google interview. You know that in MIT, there are lots of recruiters, also from Google, to find people. And then the interview process is like, okay, you have we schedule a time and pick up the phone and open a Google Doc. And he will ask you to do something. Maybe to do parallel code on the Google Doc. So there is nothing like, you see an exam and I have done this before. I can solve this problem. It's not like that. Okay? So we want to make this happen in the past and lead the project. So being a leader in a team is also important. How can you coordinate different tasks? So if you have a huge system, who is going to work on this or that? It's not a one-man team. Okay, so this is actually what we really want to learn in this class. There's a very exciting challenge in this class. And the best part is that there will be some prize. The first place will be X times 1,000. And what is X? X is probably from 5 to Y. And I don't know what's Y yet, but I don't think it's a huge amount of money, but it's interesting. Like if some of you can compete with each other and win the first place, right? So that would be very cool, and you actually develop something very interesting and useful. Okay, and you are definitely welcome to have your own project, and the criteria is that it must be usable or useful for at least one real person. Okay, it's not like, I'm going to build something and I did it and nobody is going to use it. All right, so this is probably a different perspective, but you need to find your client first and realize what's the need. Okay, being creative. Yeah, all boring projects are bad projects. So one element of creative is interesting, exciting, right? But we will probably have experts to tell you about creativity later. Teams and clients pairing. You need to form your team. And we will distribute one Duckiebot for each team. Okay. And the clients, we have, this is my college roommate. He's in China right now. And so he's confirmed. And Mr. Zhang, he's a blind user. he will come to our class. He's confirmed. And NCTU, Center of Service Learning, this is confirmed. Okay, and you are welcome to invite someone around you to become the client of your project. Okay. All right, so this is the agenda of the plan for the semester. So the first three classes will be more like an introductory courses. So today and next one, it's like a self-driving vehicle. And also the next one is about assistive technology. So you can see what has been done before, and you can say, oh, I can do better, right? And or I can get some inspiration from previous projects. All right. And from here, we will talk about the huge Duckietown system diagram, and we will cover ROS. We will have some tutorial to help you to understand what happened in Duckietown. Oh, and holiday, and you can do land following at home. Land detection and ground projection. So we will walk you through those packages and also some OpenCV. Then filter package. So it actually jumped from the detected line and try to generate the left and right should move maybe this way or that way and create a land pulse. Okay. Here. And we will also do some code reading together so that there is a code there and you need to understand it. And later, you can see how can I improve it. Or if I want to write my own code from those existing code, where should I get started? Okay, and midterm. Midterm, this is more like a showcase that you already have your project idea and you probably won't have the time to implement everything yet, but you should pretend that your technology is there and it could happen sometime and show that in the midterm. Okay. And we will also cover some of the software stuff, how to refactor in your code, how to do code review and testing, and we will have some project section for the teams. And the footwear transport challenge is here, and holiday and final exam. It's likely that we will have a poster section, so and have a very small demo, like show how your Ducky bar or your solution can do something. Some of you know how to write Android, iOS, or something. Somebody can build hardwares. My point is that yes, we encourage you to develop Android apps. Even better connecting with the Ducky bar. So I can imagine that, for example, for robotic guide dog, you can probably just use Bluetooth to connect to interface. So yeah, some idea like that. And we also encourage software-hardware integration. Okay. And although we won't cover the step-by-step instructions for those. Okay. And you can, so for example, for microcredits, or you already know how to write the program, and that's great. Okay, not covered in the class. Well, so self-learning is needed. So if you can Google something, please do it. But you are definitely welcome to ask questions, right? And step-by-step explanation for a tool. And actually, we will have a tutorial, and you shouldn't expect that people will go over the step by step for you. Okay. And start from scratch coding. Maybe you say, oh, I don't know Python so well, so maybe I will start from Hello World. That's okay. That's for your learning style. But we encourage you to do like learning by doing. All right, and let me show you this one. This is Daniela. I introduced her earlier. Maybe some of you have seen this on TV. Yeah, this is Daniela Ruth.
My big dream is what I call pervasive robotics. A future where robots are available to anybody, anywhere, where it's as easy to use a robot as it used to be a smartphone today. Robots are not replacement for humans. Because robots are really good at some things. They're really not so good at others. Robots are also not as good as we are at figuring things out, communication, interaction, and even at tasks that involve innovation, especially when it is about very fine manipulation that involves delicate objects like paper or vegetables in a kitchen, things like that. So I really believe the future is both kinds of robots working together, where the humans and robots make symbiotic teams, where the robots do their thing, and then robots are able to communicate with people in natural language and ask for help. One application or several thought has to do with removing batteries that are accidentally swallowed. In the US alone, about 3,500 batteries get swallowed by kids. And removing the batteries is very important. So you make an origami robot that's the size of a pill, and then we freeze it. So we put the origami robot in an ice capsule. So then you swallow the ice capsule. The robot gets inside the stomach, the body heat melts the ice, and then the robot unfolds in its three-dimensional structure. And then the robot has a magnet in it, and an external magnetic field can be used to direct the robot where the battery is. And then the robot makes contact with the battery, pulls it out of the stomach, and then eliminates it to the digestive system.